So the first thing is that when you first learn Pythagorean Theorem, they teach you the order a squared plus b squared equals c squared. We're going to switch it around. Is it equivalent? Absolutely. But c squared coming first, how we write down things in math makes much more sense to us, okay? Get it in your heads now to reverse the order of how you know it. When you take the SATs, this is what they're going to give you on a formula sheet. They'll give you this order. Yes, it is no different, but it'll mean more to us, and you'll see why shortly, okay? So what I just said was converse of the Pythagorean theorem is going to prove whether a triangle is a right triangle or not. Your example is going to look a lot different, okay? So your example may look like this. Tell me what's different here than the last one I put up for you. I have all three sides. You're not finding a missing side here. You're looking to see, is that a right angle? Is this a right triangle? Okay? I use the Pythagorean theorem. Only this time, it's a question. Does c squared equal a squared plus b squared? Okay? What side has to be c? That's it. So 15. And the others do not matter. Okay? 15 squared is 225. That's 81. That's 144. What is the sum of the squares of the two shorter sides? It's 225. So what does that mean about this triangle? Because the Pythagorean theorem is satisfied, that means it's a right triangle. Let's put into words what the converse of the Pythagorean theorem says. And I'm going to take the shortcut a little bit. So it says that if c squared is equal to the sum of a squared and b squared.
So we're waiting for the converse.
Yes. Then the triangle is a right triangle. So this is like your notes.
Instead of 2 sum of a squared plus b squared, can we just write c squared equals a squared plus b squared?
You can.
Doesn't mean anything different.
What?
Doesn't mean anything different.
Okay. So let's take a look at a situation that doesn't work. Okay. What if I gave you some triangle, and we're aware, I just said that it didn't work, but I just want to see it, right? I'm going to give you this triangle, okay? First off, can this even be a triangle?
No. Oh, wait.
Yeah, 11 plus 10 is? 21 is over 20, so you're good, okay? Let's see if it's a right triangle. So I'm going to test c squared equals a squared plus b squared, right?
Do you want to try this in our examples?
You don't have to. It's up to you. Kind of like squeezing it in, so you don't have to.
So should we just leave that blank?
Yeah. That's fine. You'll have enough examples next class. 20 is the longest side. A and B don't matter. Okay? 20 squared is 400. I mean, it should be pretty obvious at this point it's not going to work, okay? 10 squared is 100. 11 squared is 121. And the sum of those is what? 400 does not equal 221. That means it's not a right triangle. we can tell what kind of triangle it is. We can not only classify this by side, because that's easy. 10, 11, 20, no congruent sides, that means it's scalene, okay? But I can use what I just found to classify it by angle. Let's take a look. 400 c squared ended up being greater than the 221, which is what a squared plus b squared is. When you end up, it's an awful attempt. There we go. Okay. When your c squared ends up being greater than your a squared plus b squared, it tells you it's an obtuse triangle. So it's not a right triangle. This triangle would be a scalene, and I'll write it down for you, obtuse triangle. Okay? Similar to that would be if I gave you a triangle that was 7, 8. Okay? Let's see if it's a right triangle. How do I see? Well, first off, it's isosceles, right? Because you have two congruent sides. So it's isosceles by side. Let's see about the angle, okay? So we're looking to see, is it a right triangle? We now know how to see if it's an obtuse triangle. Let's see what ends up happening here. 8's got to be C, right? A and B particularly do not matter in this one. Okay. 8 squared. 7 squared is 49. 7 squared is 49. And 49 plus 49 is 98. This time, it ended up being that c squared was less than a squared plus b squared. What do you think that means about this triangle? This is an isosceles acute triangle. This is the Pythagorean inequality theorem. Okay? It does come in 3, but the 3 is the converse. Okay? So the first one, if, you can write this in your notes, if c squared is greater than a squared plus b squared, what does that mean about my triangle? That's right. When c squared was less than a squared plus b squared, it gave me, that's right, an acute triangle. There is technically a third part of this, and that's the idea that when it's equal to, it's a right triangle, which you kind of already wrote, so you don't have to rewrite it, but you could if you want. So if c squared ends up being equal to a squared plus b squared, then it is a right triangle. Okay, so I'm going to go kind of a little fast, but I'm actually going to give you 3 examples. So you can actually now go back to that bottom part under the converse where I didn't give you an example. Let's look at an example of that now. Is everybody good here? Yes? Okay. Here we go. So, the first thing I'm going to say is we first have to identify whether this could possibly be a triangle at all. Can this be a triangle? 40 plus 9 is?
Yes.
49. It's over 41, so you're good. Okay? Now we're going to look to classify it. Now, we already know that it's going to either be a right or not because I told you where to put it in your notes, but Theoretically, we're not always going to know that, okay? So we're testing to see the comparison between c squared and a squared plus b squared. Okay? So c has to be 41. And a and b don't matter.
Wait, are we putting this in the example box underneath the Converse?
Yeah. Yeah, I was right. Okay. Making sure my math is right in my head. Okay. 41 squared is going to end up being 1681. 9 squared is 81. And 4 squared is what?
16.
16. Add how many zeros? 1,600. 2 zeros. Like 10 squared is 100. 1, 2 zeros. 20 squared, 400. 2 squared is 4, 2 zeros. Okay, so that means that 1681 is equal to 6081, and that gives me a true statement. Because c squared is equal to a squared plus b squared, what does that mean about these? It gives me a right triangle. What about by side? No congruent sides, scalene, right triangle. Okay. Quick. Let's look at when you have a less than, okay, or an acute. So we had 787, right? It's another scalene, but that's fine, okay? So 12 squared compared to 10 squared plus 11 squared. Okay, can it be a triangle? Yeah, you're plenty safe here. 10 plus 11 is 21, way over 12, okay? 12 squared is 144. That's 100. That's 121. 144 is definitely less than 221. So what does that mean? Okay. We don't have time for that last example, but that's fine. You've seen 2 obtuse, okay? Flip it over along with the evens on the other sheet. So 2 through 16 even on the other sheet. Do 1 through 4 on the back of this sheet. I will for when I'm out next class, okay? 2 things. Just really quickly listen to me so you know what you're doing. I am going to leave you the answer key to the homework that you're doing right now, okay? I'm giving you plenty of review. You have 2 big packets for a very small quiz, okay? You will have lots of practice with them. I'm also going to post an answer key to them. I've officially switched over everything to Google Classroom because I find that you guys can find it easier, okay? So everything will be on Google Classroom, okay? After you complete your packets, go on Google Classroom and check your answers. Make notes to yourself when you don't understand stuff because we'll have about 25 minutes before the quiz on Wednesday to talk about it. Then, this is important, there's also going to be videos posted from today, so if you're confused, check them out. Also, I am posting 1 video that's about 3.5 minutes long. That is it. It is on the distance formula. Some of you may have seen it in the past, okay? You should watch that video on your Chromebooks in class on Monday, okay? take notes on the sheet that the sub gives you and try example number 1. But she'll reiterate these directions to you. Okay? Sound good? Have a great weekend. What's up, Brad? Oh, thanks.